Okay, hello everyone, and welcome to another Analytics Masterclass. We're gonna take a look at several terms today. We're gonna take a look at data science, understand the base for everything AI. We're gonna take a look at how we can convert raw data into something that can identify images that's building a predictive model. Today, we're gonna do all of these and even more. I'm glad that you are with us. I'm glad that you're with us. This is going to be the today's Wednesday. So I think this today we can say thank God it's Wednesday because it's going to be a fantastic session. Like I said, the next 2 hours will be one of the highlights of your day. Okay, it will be one of the highlights of your day. That's something I can guarantee. That is something that I know will happen for sure. But before we go ahead, before we actually begin, I would just like to get from us, you just have an idea of the audience that we have on the call at the moment, which will guide us in understanding what we need to do, how we should go about saying the things we are saying, how we should go about disseminating the information we are trying to pass across to each and every one of us. So that being said, I want you to send your location and your name to the chat box. So just please send your location and your name to the chat box, your name and where you're joining us from, and then we'll begin. Okay, this is one of those things they call networking because networking is a very, very big thing. Okay, it's something that each and every person should always try to engage in. So I could say somewhat this is us networking. So please send your name and where you're joining us from to the chat box. We have Tony, fantastic. Thank you very much, Tony. That's Anthony Onyido from Manchester, UK. So Tony is joining us from the UK. We have Obina. Obina is joining us from the UK as well. I need more responses. Abesek, where are you joining us from? Bright, where are you joining us from? Okay. I need responses. I need responses. Very, very important. Okay. iPhone, where are you joining us from? I think I've gotten 2 responses. Of course, we are currently texting on the call. The number is definitely going to grow as we move on. So I'm just trying to stall a bit so others can join us and so we go together. Oh, fantastic. So we have iPhone. iPhone is actually Ichendu, and Ichendu joining us from the UK. Fantastic. It seems we have more people joining us from the UK today, which would also help us in understanding how we should go about the information we are passing across. So not to waste any more time, let's just get into it and take a look at what we have for today. For many of us, I'm sure we saw the flyer. We saw that, okay, today we're actually going to be taking a look at how we can convert raw images into usable data as a data scientist. So the core of everything that we are doing today is understanding what it takes to be a data scientist. Who is a data scientist? What even is data? Okay, what is data? What is science? What does it mean to be a data scientist? All of those things are what we're going to take a look at today, and we're going to work on a case study. We're going to build a model. We are going to build a model in one. Today, you will see how you can build an AI model. AI model they're able to detect things, maybe like just as you can see from the image where you see this lady, the AI model is able to detect the face and all of those things. So we're going to build something similar today. We're going to work with Python. We're going to work with some libraries. It's going to be a great one. Okay, so just stay tuned. There was a report. There was a report that was released, I think, a couple of years ago, and that report said AI, sorry, not AI, data science is the sexiest job of the century. The data science is the sexiest job of the century, and that is actually the truth. And we are going to understand why that is the case in today's session. Okay, so stay tuned. It's going to be a great one. But yeah, we have different sections to the session today. And the first thing we're going to take a look at, of course, we're going to develop a system that can detect road traffic signs. We're going to build a system from scratch, a system that can develop. See, after you're done with the program, after you're done with the session today, you can even go ahead to start applying for jobs. Okay. Anyways, that's just on a lighter note. But you're going to see that, oh, AI is really not a big deal. and you would understand how you can go about this thing. So we're going to build a system that can detect road traffic signs today. And then we're also going to take a look at the pathway for you to become a data scientist. Okay, a data scientist. This was the typo. Sorry about that. A data scientist. And we'll take a look at the Tenalities Growth Internship Program and also a special discount offer for you. For you. It's International Women's Month, and there's something very, very big. Okay, it's something very, very big that we're offering that I will tell you very soon. But about Tenalytics, especially for those of us that this is the first time we are in a session as this, you might be wondering, what is Tenalytics, or who is Tenalytics? Why is Tenalytics? What does it even mean? Tenalytics, what is the meaning of the word even? Okay, so we might be thinking about all of those things, and there's absolutely no problem. Tenalytics is a tech firm, and what we do is that we help you transition into tech. So we make your dreams come true. You've been thinking, okay, you know what? I want to get a new job in tech. I want to get a job. I want to get into tech. I want to transition into tech. What I'm doing at the moment is not something I find really pleasing, and I would like to move into something that I can say career path, that I can say career growth, that I know that in the next couple of years, so I can move from this point to that point, and I'm not just working and I don't have a career plan, or I'm not just doing survivor jobs as it stands. You want to move into a path that you can see substantial growth. So we are here to make that dream come true. And we've been able to help over 2,850 people transition from the classroom to getting their first job in tech. Because again, we are Santa Claus, so we make dreams come true. And that is what we do. We have programs from data analytics to business analysis to data engineering, data science, financial analytics, HR analytics, HR project management, cybersecurity, and also AI engineering as well. And our facilitators are from top-notch companies. That's the Fortune 500 companies. So you know that you're in good hands when you are a part of any of our programs. So that's about analytics. That's what we do. If you've forgotten about everything, don't forget about one thing, and that is we make your dreams come true. Okay. So when you think Santa, think analytics. Simple and sweet. But what about me? Who am I? You might be wondering as well. I'm Aisha Bolaho, as you can see from the name tag at the bottom left, and I'm the lead in charge of trading and operations at Analytics. So I have experience from data analytics to business analysis, power platform engineering, predictive AI engineering, which is a part of what we're going to take a look at today. And I've been able to work across organizations from the US to the UK to Canada to Singapore and also at Nigeria as well. And I've also trained over 2,500 professionals across 4 continents. So that's me. Okay. That's me. I love data. I love data. I love tech, and I love chess. Chess, okay, chess. That's a good word, chess. Yeah, and with me, I have Daniel. So Daniel is also a fantastic professional. He's a senior data science associate at Analytics, and he has over half of a decade of experience from ranging from data science, data engineering, and also the IT space. So he has been able to work across different organizations as well, training individuals on data science and helping organizations implement data science and AI strategies into their critical business processes. So Daniel is going to take us through she's going to take us through building that model. Don't forget, we are going to build a model. We are building a model that will be able to detect both traffic signs. Okay, it's an exciting project. Trust me. I am myself. I'm still going to be practicing alongside Daniel. So Daniel's going to come in and get all of that for us and show us something amazing. And when it's done, I will come back in and tell us about something even more special. I'll tell you a story and then we'll have some fun. Okay, so that's it. So Daniel's gonna come in, show us everything that we need to see, know, and everything we need to do as we get AI, as we get building this model. Then I'll come in and we'll have some fun because I'm the fun guy. Okay, so just stay tuned while I call on Daniel. Hello, Daniel.
Hello, Isosa. Good evening.
Yeah, hello. How are you doing?
Yeah, I'm doing fine.
Oh, okay, fantastic. So, yeah, you can go ahead. You can go ahead. I'm just gonna
All right.
spotlight you.
Good evening, everyone. So I need your reaction. If you are ready for this session, I need your reaction. In the chat box, you can give a thumbs up. You can give your favorite emoji in the comment section. So I'm waiting. I'm waiting. All right, all right, all right. So, okay. So, welcome to tonight's meeting, and we are going to have so much fun within the time that we have. And for many of us, this might just be our first time in data analysis or seeing how data science is being used in a real world case. And so, just like Isosa had described, we are going to be working on a very interesting case study. Many of us here have heard about automated cars that autonomous driving, and how we wonder how they're able to navigate, how they're able to move from one place. They're able to identify the road signs, they're able to get to know when to stop and all of those things. So you might wonder that, okay, so how do these things work? So we are going to do something, a very small project this evening that will demonstrate a bit of all of that. And so I'm going to walk you through everything from start to finish. So I'm going to share my screen now so you can see what we are doing tonight. All right, so here we have it, our case study we are going to be looking at. So we want to develop a system that can detect road traffic signs. And as you can see, if you look at the picture I have here, we can see a busy road, not so busy though, but on this road, we can see different signs, we can see the traffic light, we can see the speed limit signs, we can see various things, zebra crossing, and several other things like that. We are wondering that, okay, how do I do something like this? How do I create a computer vision project that can identify something like this? So we want to do an end-to-end project this way. And so first thing, we want to look at what problem are we solving? So we know that in an urban environment, traffic management is very crucial to ensure road safety and efficient transportation. So, but there are different struggles with identifying and responding to road signs. So we want to propose an AI traffic road system detection system that can leverage on computer vision and deep learning and to recognize and classify these road signs in real time. And so this system will be integrated into vehicle dashboard, driver assistance, and helping drivers receive visual alerts during driving. So I can focus on my driving and let my car do the vehicle detection. Won't that be a wonderful thing? You are driving, then the car will be telling you that, oh, there's a stop sign here. There is a speed limit here, 30 mph. Please slow down. You don't have to watch the road. Yeah, in quotes, your car can do that for you. So we want to do something that would help us to achieve that. So I need your emoji if you are ready for us tonight. So what are we going to use? We are going to use our OpenCV, we are going to use Python, and then everything is going to be written in our Jupyter notebook. All right, so where do we start from? The first thing we're going to start with is we want to recognize, we'll be creating a model that can recognize if there is a traffic signal. So that means as the vehicle is moving, the vehicle wants to tell us, okay, I can see an image. On this image, there's a traffic signal there. And so we are going to look at something like this. So you should be able to build a model that will tell us that, okay, see this sign here, this is the raw sign it's seen, and then it's telling you that, look, I've noticed something here. And then when you are done, we'll now create a model that will now tell us what type of traffic signal it is. So that means once we've been able to identify that, oh, this is a traffic signal, what type is it? So here you can see our label tells us that, oh, this is a stop sign. And so this is what we want to so this is what we are aiming to achieve tonight. So let's get into the lab. I'm going to share my screen now and let's get working. Okay, so as you can see here now, I have a blank worksheet, and this is my Jupyter notebook, and this is going to serve as my worksheet. This is where I'm going to write all the codes that we are going to do tonight, and you're going to see that it really doesn't take so much to get started in the area of computer vision. And doing advanced stuff. Now, so now let's look at what we are going to do. Now, before we get started, I'm going to show us what our data looks like. So if you look at this, so this is a sample image I used the other time. If you look at this particular image, you will discover that, oh, this image contains a stop signal. I want to be able to determine that, oh, there's a stop signal in this particular image, and then we can use this detection to go through our first part. So what do we do first? In data science, one of the first things is data collection. Now, you want to collect your data, you want to analyze that data, and then you want to use that data for something very meaningful. So now let's get started. Let's take in our data. Let's see how it will look like moving this data from here and moving it to our workbook. So I'm going to start with the library that is going to help me with that. So the name of the library I'm going to use is CV2. Now remember when we talk about the tools we are going to use, I talked about OpenCV, I talked about Python, and I talked about Jupyter Notebook. So this whole work environment is our Jupyter Notebook, and the Jupyter Notebook is running on Python, and then our Python is, we have a library called our OpenCV. So the OpenCV is what is imported here as our CV2. So now I've imported my library. The next thing I want to do is to import. So I've imported my library. Now everything is working fine. So it shows that I'm on track. So the next thing I have to do after this is so the next thing I want to do after this is to bring in my image. So you see the image we're looking at the other time. I want to import it now. I want us to see how the image will look like. All right, so let's look at how the image will look like when we import it. So I'm going to import the image so that we can make use of it. And it was not 6 years. Okay, so I have my image. So that's what I'm going to give the name of the image. I'm going to do image, then cv2.imread. So imread is the name of the library I'm going to use to read my image in. All right, so now I have my imread, and then I have my, I'm going to write the name of my image. So my image is under the folder called data. So let me show you how my folder structure is. So I have my signals, I have my data. Now inside my data folder, I have my image. So this is the image I want to work with. So I'm going to tell you that, okay, I have my data, and inside my data, I have my image.jpg. And so I'm going to do my image.jpg now. And with this particular line of code, I have been able to, so with this particular line of code, I've been able to read in my image as it needs to be read. And then, so the next thing I want to do is that I want to see the image to be sure that what I've read in, I've been read in properly. All right, so now we have, let's visualize it. So I have my matplotlib.py plots, and so I'm going to use this py plots to to show the image on the screen. So I'm going to do plt.im show, and so I'm going to put in my image here, and then I'll run this. Okay, so if you look at this now, you can see that our image is a bit it's not showing the same color that we have. So who can guess what is actually going on? Who can tell us what you think is going on with the image? Why do you think it's not showing as it ought to show? Anyone? Just type it in the comment section if you think you know why. So I need opinions, please, so I know you are following. Why do you think it's not giving us the same image as we ought to have? We are expecting. We are seeing a red image there from here, and then, okay, thank you very much. No types in red. Very good, Tony. All right, so we have this red here. Okay, I did not specify the color. All right, thank you. So I love those ideas. So now let's see what is happening behind the scene. So what is actually happening behind the scene is that when we have images like this, so we have whenever we are reading it with what we have here, which is our open CV, our open CV reads in our images for us in an image format we call BGR. So this is its BGR. B, G, and R. So which means that blue, green, and red. However, our image was originally stored in RGB. RGB. So what we need to do now, if you are going to see our image in the actual format that we are supposed to see it, what we are going to do is that we'll convert the image from this BGR format to RGB. And if you can see, you see that this red was read in as blue, and then we still have our white and other colors inverted. You can see that the green is maintained, but the other shades are not maintained at all. So this is the effect. So when you are reading it, make sure that you know the format for which your image is being read in. All right, so now let's do the conversion. So the first thing I'll do is that I'm going to convert this image from BGR. I'm going to convert it to an RGB image. So now let's do the conversion. So I'm going to call it IMG RGB. So that's to tell me that this particular image is being converted from BGR to RGB. So I'll have my CV2 dots, and then I'll have my convert color. I'll have my convert color, CVT color, and then I'll specify what image I want to convert, which is this image. So I'll have image here, and then I'll now tell you that, okay, so I want to convert this image. I want to convert it from, I'll tell you the type of conversion I want to do. So that is from BGR, as we all know, and we are going to convert it to RGB. So whatever we have here is our image in RGB. So now let's look at it. IMG RGB. So let's look at IMG RGB, a small letter here. Now, one thing about Python is that Python is very case sensitive. So whatever you are using in your Python, you must remember the case. So if here is my IMG RGB in all small letter, then you must ensure that it is small letters all through. So now let's run this and see what we have. All right, so our image now displays correctly. Our image displays correctly. So let's see now quite a few things that we don't want about this image. Number one about this image is that we don't want all these numbers showing. These numbers are showing that, okay, 0 to 100, all these axis number, we don't want them. So we want to remove them. And let's see how we can remove the axis number. So I can do PLT dot axis, and then I'll put off here. So what I mean is that turn off those numbers. And you can see here, I have all of those numbers off, but I'm having another number here. All right, so I don't want that. I can put my semicolon here, and let's see. And fine, everything is working fine. Give me a thumbs up if you are following me so far. Give me a thumbs up if you are following me so far, please. So I'll know I'm not alone, and then you are enjoying the class. All right, so I'm here because of you. All right, all right. Thank you very much. I can see your thumbs up. Okay, now to the next part, which is that we want to now detect that this is actually a stop sign. We want to detect that this is a traffic signal. So how do we go about this traffic signal detection? All right, now the next thing I want to do is that I'll now bring in a model that will help me to detect the traffic. But then there's one thing there is something about this image that I need to tell us. There are so many information that is hidden in this image that we cannot see. And we need to harness the image, those information for us to be able to achieve our goal. And now, one of the things about this information is that the size of the image. Now, because this is a colored image, remember the initial illustration I gave us, which is that an image is loaded as either a BGR or an RGB. In this case, when you use your CV2, it's loaded as a BGR. Now, what we want to do is that each one has its own information that is storing in this image. So by the time you bring blue, you bring green, and you bring red, and you join them together, all of them will now give you this stop signal that we are looking at. But then, if all of them is bringing their own ideals, everybody's bringing their own, there will be too much for me. There will be too much information for me to handle. So what do I want to do? So let's look at how much data we are having in this image. Just this image alone, how much data does it contain? So I'm going to do what we call IMG then RGB. Remember, we've changed our image. So to RGB image. So I'm going to do dot shape. Now look at this dot shape. Let's look at what it's telling us. It's giving us 551 by 5979 by 3. So this is the width and the height. So it's telling us that the image is 551 high and then 971 long. Then this 3 is telling us that there are 3 channels, which is our red channel, our green channel, and then our blue channel. Now, what is the implication of all these 3 channels? Now, the implication is this. Each of them, we have 551 in width and then 979 in length. Now, let's calculate how much data we have to carry along. So because there are 3 channels, which each one having its own height and width. So let's calculate how many it will be. So that will be 551 times 979. So if I do my enter, because I can also do my calculation from here. So if I press enter from here, I'm going to have 539,429. So that means for a particular channel, is holding 539,429 pieces of information. That's just for one channel. Now I have 3. So now if I'm going to consider the number of information I have for those 3, that will be multiplied by 3. And that will be this. So that will be 161,8287. And that will be 1,618,287. That's quite a lot of information in one image. Now, it does not look like it, isn't it? It looks like, okay, so you mean I have 1 million information in this image? Yes, this is just one. So imagine I now have to work with 1,000 images. So 1 million times 1,000. I'm going to be having, so let's multiply it by 1,000. That means I'm going to be having a billion data to work with on this my computer. So I'm going to be working on a billion data. That's quite much, right? So there should be something we can do to reduce the image. We can reduce the image and then the number of data we have. And this is what gives us this particular idea that, okay, so if what I'm concerned about is just to identify whether this image is whether this image is just a traffic signal or not. I'm not doing much processing here. I just want to see if it's a traffic signal or it's not a traffic signal. So all I just need to do is that the color of the image does not matter to me. So that means whether the image is colored or not is not a priority. I can do without the color. Do you understand me? So give me a thumbs up if you understand me. I can do without the color. So if I can do without the color, so let's get rid of the color and let's put our image in another format that does not have color. So once we go back to natural colors, that is gray color. All right, so now let's look at this. So how do we do that? How do we convert our image to gray color? So I'll have another variable called img RGB. So sorry, img gray, img gray. So this img gray is a way to convert my image from colored image to our gray color. So now here, remember our image is a BGR image because we read it in with our CV2. So I'm going to do image now. I'll have my image, comma, CV2 dot color. So I have several color options. So I'm going to only stick to BGR. Yes, so BGR to gray. BGR to gray. So what that means is that I'm converting my color from BGR into a gray image. So I'm going to change this from gray image. I'm going to change it from my RGB. I'm going to change it to gray. So what some of us we call black and white. All right, so let's see black and white image. Let's see our black and white image and see. Whew, wow, not exactly what we're expecting to show, right? So we've removed the color. So why is it giving us this? Okay, so let's see what we can do to change this. Now, whenever we are importing, want to view our gray image like this, whenever I want to view our gray image like this, all we're going to do, we put our CMAP, and in our CMAP, we're going to tell it that the image I want to visualize is a gray image. So once I tell it it's a gray image, it will understand coded language, bro to bro, man to computer. So only us understand our language. All right, so that's by the way. Okay, so now when I put that, so once I put that, it tells me that, fine, I understand what you're saying now. Let's go there. So it has given my image as a gray image. So whatever I'm going to do now, I'm going to do it with the gray image. So looking at this gray image now, that's what, let's now check our shape. Unlike what we have before, we have we had 559, 551,979,3 for the shape of the colored image. So now for our gray image, let's look at the shape and see what we have. So img gray dot shape, and we have 551,979 for our gray image. So now this gray image is what we are going to be working with and further analysis. So we have reduced our data from, we have reduced it from 1,618,287,000, 287. We have reduced it now to 551 times 979. All right, so if you look at this, so we have 539,429. So now we now have this, and this makes it very excellent. So we don't have to bother ourselves about working with this much data when we can work with this less data, and we are going to get the same amount of information. All right, so let's go to the next item. Let's go to the next session. So we've been able to convert our image, and all right, so let's see how we can now use that image to carry out our modeling. And now the next few steps is very surprising, because you'll see that we are not going to do so much coding, and we are going to get our results. So now I want to create my model. So let me say signal model. So signal model equal to, so in this signal model, what I'm going to do is that I'm going to have our signal model, and I'm going to call in my what is called my CV2. My CV2 is very important library for us in what we are doing. So I'm going to, in my CV2 now, what I need now is a cascade. I want to do my cascade classifier. So I have already what we call pre-trained data. So this pre-trained data is what I'm going to use to get my work done. So now let's look at our pre-trained data. We have, if you look at what I have here, I have all.xml, I have stop data.xml, So now this top data.xml is only useful when I have, maybe I want to check for stop data, but it's not only for stop signal I want. I want to check for several traffic signals. So I'm going to use, so instead of using stop data, I'm going to use my all.xml. So this is what we call cascades. So this cascade, what we call higher cascade, they have been trained by several other users. And as they have been trained, we can now make use of those trained data to achieve what we want to achieve. So now I don't have to start training to identify. Remember, the first aim here is to identify traffic signals. The next one we are going to do is that we are now going to create a model that will tell us the type of the traffic signal. So now, since they have already done the model for us, giving us a hard cascade that can help us to identify whether we have a traffic signal or not, we can just make use of that. So as usual, my data is always kept in a folder called data. And so I have my data, I put my comma, and then I put my all.xml. So now let's run this and see what happens. Let's run this and see what happens. And so when I run this, nothing happens. Okay, so let's see. Is it that my image is not working or something like that? I don't know, but let's see. But we've created our model. That's it. So now let's see how we can apply that model to what we want. Let's see how we can apply it to what we want and make it work. All right, so now let's see. The next thing I want to do is that I want to now use this model to dictate data. So in as much as I have created this, the data is not useful if I don't apply it to something. So I have to now apply the model. I have to apply it to an image. So it is from that image I can now detect that, okay, there's something that is wrong in this particular image. So let's work on that thing that is wrong in the image. So let's look at how we can use that model. So now I have my signal model. So I have my found. So I'll say find or found anyone. So I can say find signal. I can say find signal. So now let's find signals. So I'm going to do my signal model dot detect. So what I want to do is that I want to detect multi-scale. Now, what that detect multi-scale is saying is that I want to detect several objects within that text. So I can now specify several other parameters that I want to go with. So let me know if you are still following me so far and you're enjoying the class. Please drop an emoji, drop a thumbs up. Let me know if you are still following so far. All right, so now the model detects, we want to use it to detect our stop signal, which is the hallmark of what we are doing in this particular session. All right, so now we have detect multi-scale, and I'm now going to tell you that, okay, so I'm detecting my multi-scale, and after detecting my multi-scale, I have what we call my image. So I'm going to supply it my image. Now let's put my image there. So the name of my image, remember the image we are using is our grayscale image. So I'll say image img RGB. So now I'll now specify other parameters. Now, what are these parameters that I want to specify? But before I specify those parameters, let me just stop here for now. Let's run it and see what it finds. So now we are done, and let me run it again. Does it find anything? Let me do find signal, and let's see if it finds anything. Okay, so as we can see, if you can see, you see that there are so many things here. There are so many numbers, several numbers, like I don't know how many there are, 1, 2, 3, 4, 5, 6, 7, and there are just many, and we don't know what those numbers are actually representing. So now let's see what those numbers are representing. Now, one thing I can tell you now is that because I have these numbers, it shows that my model has been able to detect something. Now, what did it detect? I don't know. Did it detect what I wanted to detect? I don't know. But I know that my model has been able to detect something. And that's why I have this. Don't worry, you can go over the videos, and I believe we find an application for it. Minat Tijani. So now we can find, so I found my different signals. So now let's see what is found. Let's look for what it found, and then if it's actually doing the work that we sent it to do, or it's just doing what it likes. All right, so now let's see. So let's see. What we are going to do is that those lines, those things you are seeing here, those things you are seeing here, they're actually representing box. They're actually representing box. They represent the XY width and the height. So those are the things you are seeing here, all those lines. So we want to draw, so we want to convert these numbers you are seeing, we want to convert them to images. So when we convert them to images, we'll be better able to interpret this line. Because for me, what I'm seeing here, I don't understand. I'm as confused as you. All right, so let's clear our confusion and then turn it to pictures that all of us can better relate to. So like I told us now, for the fact that there are numbers there, it means that it has found something. So, but what did it find? That is the question. So the box will help us to answer that question. So this is what we are going to do. So I'm going to say for x, y, width, I can use W and H. So width and height. So the first one is the X, the second one is the Y, the third one is the width, and then the fourth one is the height. So now, we now say for X, Y, W, H in this find signal. So all of the things it has been looking for since, let it tell us, let's help us to plot it in something that I can understand, all of us can understand. So now we now tell you that for each time you go through this, so that means for each one of these, extract all these 4 information for us. All right, so now let's see how we can now use it to plot. So I'll now tell it that, okay, so let's draw a rectangle from here. So I'm now going to say, okay, so your rectangle like this. So I'm going to do CV2 dot rectangle, CV2 dot rectangle, and I'm now going to open my brackets. So as I open my brackets, I'll tell you that remember, even though we use the gray image, this was the gray image that we use to train the model. Remember when I told you in the first place that the reason we use the gray image to train the model is that the gray image contains less information than the colored image, but it does not change the identity of what we are trying to work with. So that means we can still get our results with the gray image. So now I'm now going to go back to my color image. I'll now tell you that that thing you saw, go and draw it on my color image, not on the gray. So the gray is done with its own work. All right, so now let's do image and IMG. So I'll do my MMG RGB. So that's my image. And then the next thing I'm going to do X, Y. So that's my first coordinate. Then the next coordinate is that I'm going to specify my 0. I'm going to specify my second part, which is my X plus height, and then my Y plus width. So now what this is telling us is that I want to draw a rectangle. So the way it works is that it needs just 2 corners. It needs the bottom corner. It needs the bottom corner, and then so it needs something like this. So it just needs us to tell us where is the first corner located in. So where is the first corner? So first corner, second corner. So automatically it's going to fill it in all of this. And that's why you see I have X, Y representing the first corner. And then I have X plus H, Y plus W to represent the second corner. So the computer will automatically generate the remaining boxes for us. So now let's see what the computer has been able to generate for us. And let's see if what it generated will answer the question that we are asking. All right, so the next thing I want to do is that I want to give it a color. So I can give it any color. But I want to give it green. So I'll do 0, 2 to 5, and 255 and 0. Now, the reason I'm doing 0, 255 and 0, remember our color coding. We have 3 channels. whenever we are using CV2, CV2 has blue, green, and red. So when I say 0, it means that turn off red. When I say the first one is 0, it means that turn off the blue color. When I say the last one is 0, I mean turn off the red color. When I now say the middle one is 255, now the range of values for color is from 0 to 255. 255 is the maximum. So when I now say 255, remember the middle color is green. So 255 is the greenest green that is possible. So no, don't mix it with red, don't mix it with blue. Just give me my green alone, as green can be. All right, so I don't know if that English is acceptable. Okay, so now the next thing I want to tell is the thickness of my line. So I want to put my thickness, my line thickness, and let's see. Let's run this. Let's run this. So now, I know many of us are very eager to see the outcome, but it's not giving us the outcome. So we finish running, we finish drawing our rectangle, and we are not seeing anything yet. Okay, so what's going on here? Let's see. Let's now see the image. So who can tell me, why do you think we've not seen the image yet? Yes, it is. So why do you think we've not seen the image yet? Who can tell me? I need one person to tell me why we've not seen the image yet. We've been doing all sorts of manipulations since, and the image is just not showing. Why? So who's telling me that's why are we not seeing the image yet? Okay, I should show signal. Awesome. So let me show signal. Yeah, so I'm going to now use my my yeah, prints. Okay, so this time around, the way to show print signal or the way to print, because I'm using images, so I cannot just use print statement. I cannot just tell you to show me the signal just like that. So I'm going to use what I call the show signal. I'm going to use my PLT. That's the same library I have here. What I use here to show it is what I'm going to use. So all I just do is copy this. I'll copy this. I'll paste it here. So now this time around, when I paste it, I'll change the name to RGB, and then I'll remove this CMAP, and that is all. So that's the only change I need to make. And so let's run this and see. And yes, finally, our signal has shown. So now tell me, who can tell me, has it been able to detect the traffic signal? And what else did you notice here? In as much as it's been able to detect the signal, what else do you notice? Anyone comments? So what have we been able to see? So we can see that it detected the signal, but it's detecting noise. Is descending different boxes around it. Awesome. You're following along. So you're already becoming a data scientist here. Okay, so just like I said, you can replicate this project and then put it in your CV and say, wow, this one of the project I did. Okay, so now it's replicating noise. But one of the things you can notice is that outside the noise, you can see that in terms of size, we have the stop signal itself is a little bit bigger than the other smaller blocks. So that means we can say, okay, look, nice one, you tried, but please reduce the number of noise that you have so that we can be focused on the main thing. And so if you are going to be focused on the main thing, how are we going to do that? So we are going to do something like this. So we'll go back. Remember I told you that our detect multi-scale has many parameters that we have not explored. We only explored one. So I'm going to now tell you that, see, those small blocks are noise. Those small blocks, they are noise. They are disturbing us. I don't want it. So let's go and remove those noise. And so I'm going to do something like this. So I'm going to say minimum size. So I'm going to define the size of my block. So I'm going to define the size of my block. Yes. So I'm going to define the size of my block. I'm not telling you that the minimum size that it should carry. I'm not going to tell you that, all right, so let's do a minimum size so that we'll not just carry everybody along like that. So minimum size, I'm going to specify the width and then I'm going to specify the height. So once I specify that, so let's do some test run, 100, 100. Let me see what that gives us. So let's go back and rerun this. So this and this. So a size of 100. So I'm not seeing anything. Okay, I didn't run this part. I'm running this now. I'm running this. So you can see that the smaller boxes have disappeared. So let's still change the size a bit. Let's take it a notch higher. So let's do 200 and see. So let's do 200 and see. Okay. So 200 is still giving us this. Okay, so we did not rerun. Yes, so let's rerun the previous codes and then let's do this and let's run this. And so we are done. We have gotten our model. So we've been able to take our model from here, an empty signal, and then we've been able to get it to this point. So you might want to ask me that, okay, so how am I sure that it will work on other things? How am I sure that it will work on other things? Yeah, so we're going to try out some other images. So I'm going to move one or two images. I'm going to bring in one or two images that we are going to use to try this out again and be sure that uh, we have our image running. We have everything going on fine. All right, so let me bring up an image now. I'm trying to move my images into my folder so that we can work with it. Okay, so let me get several images now. Okay, let me take one from my training images. All right, so it's taking time to load because the size is quite large. So I'm going to do that from my back end. So you can see that it's taking so much time to load because the size is quite much. So I'm going to go back and let me close this. Let me close this. So this is the dilemma of a programmer many times when you have to work with a large data set and then everything just keep you freezing. So, but that's not a problem where we can't solve. So I'm going to go back here and then, yes, so exit pages. So because of the size of my data, I have this, so I'm going to work from my folder. All right, so that's nothing to worry about. Sometimes we have moments like this, so I go back to my folder and then I reload. I reload this. Yeah, so I'm back up. I'll close this folder. I'll close this too, and then I'll close this. Yeah. So I'm going to open the image from my backend and load it where I want it to load. So just I'll do that in a jiffy now. All right, so I've been able to copy some images due to our time constraint. So I was only able to get one image out so that we can use that to check that, okay, so this thing is actually working. So let's look at this image. Let's look at this image and see, okay, so we have something like this here, and then let's see if it can detect it for us. Let's see if we still need more tuning and all that in our image. So I'm going to change this image name now. So I'm going to change this image name now. And then I'm going to do this. So sometimes if you are not too sure of the name, because this name is quite long, so I can just do my tab and it's going to show me all the files in my folder, and then I can hit enter here. All right, so yes, and we are good to go with this image. So let's look at how the image looks like on a grayscale. So this is the image, and then let's run this again and let's see how it looks. And all right, so we have this image. It also is able to detect for us, but we have these tiny, tiny images there that are interfering. Now, let me tell you why the interference is like that. Now, the main reason the interference is like that is because this data is containing small images. You know, remember I said we have this particular cascade is covering different kinds of road traffic signals. So there is a what we call false positive. False positive is the fact that it is able to capture something that is not it. So for example, now it tells us that, oh, what I'm seeing here looks like a traffic signal, which it may not be a traffic signal at all. So that's one of the reasons why we say it captures false positives, because it has all of them. So the best model to use is the one that are particular in nature. So that means the ones that have um that means the one that has just, okay, this one is for stop, this one is for right, this one is for left. Now if we have those kind of models, it's going to make it easier for us to, okay, detect only one thing, but then we want something that is very robust, and that's why we have this. And so I had to bring this, and that's why you have so many noise in our detection. So now let's see, we have several smaller squares also, so let's see if we can reduce the square. And um we used the size, we use the size 100. So let's see if we can reduce the size to 200 and if we can capture it better for us. So let's drop this, let's run this. And as you can see, when I dropped the size to 200, you can see that it captured my size, but you notice that there are other smaller squares on it. And so the reason is that I did not change the image again. I'd already asked it to draw on the image. And so I need to change the image before it will reflect, or else it will just keep drawing on the same image. So now when I switch my model, you can see that everything is working fine. So that means we've been able to build in this short time we have been able to turn an ordinary image, an ordinary traffic image, we've been able to turn it into something very unique. So imagine now that I have a car and I have this model. So your car, your dashboard now, the dashboard of your car, you have a cam, you have a webcam on your car. Now that webcam is capturing images as you are driving. So the next thing that it does is that it will now tell you that, oh, I have what we call I'm seeing something on the road, and let me check, is it a road traffic signal or it's not a road traffic signal? Okay, this is a traffic signal. All right, so this traffic signal, what kind of signal is this? What kind of signal is this? So we've been able to capture this. We've been able to capture this and capture the different images. So you can see how interesting it is, how useful data science is in real world. And the second part, which I want to do this evening, which is not going to be completely end to end, and I'm just going to show us how I got the final results and all of that, just to give us a glimpse of how this model works, is that I now want to take this model and tell it that, look, this particular model, I want to tell you that, see, so I'm going to show us how we can now take those images and then now convert them into a proper model, machine learning model. So we've been able to take the images and convert them into road traffic signal. So the next part is now I'll show you how to load your data, convert the data, and then I'm now going to show you what the final outcome is going to look like. All right, so if you're ready for the second part, just give me a thumbs up. Give me a thumbs up or drop your favorite emoji. Okay, Oluwafumi, sorry. You were asking a question, Abebi Minat. All right, so 0,255,0 only applicable to the tiny square detector. No. It's a number format. So different numbers require different formatting. So we have what we call hex, we have the RGB, we have the BGR, we have the HSL. So this 0,255 now can either be used in any application. So you can use it in your, I'm trying to remember now. You can use it in any application at all. So any format can be used, anyone at all. It can be used. So it's not limited to this particular one. All right. So thank you very much. Thank you for following me along. And I hope this is not the last time I'm going to see us. I hope to see us in class, all right, so that we can do more stuff. We can do more in-depth things than this. All right, so now let's continue this and let's see what we can do. So it's a bit lengthy process, so I'm just going to walk us through. I already have the completed part, so I'll just walk us through the thinking process and I'll show us the final outcome. So let's go. See, okay, so if you can see my screen now, you see that I have my data. I have a folder called car. So in that folder, because if I open it now, because of the size, it might cause us to have some breakage and all that. So I'm going to explain what is in there. All right, so now in my car folder, I have 3 folders. I have the test, I have the train, and I have the valid. Now, what are those 3 folders? Now, those folders are containing the images that I want to use to teach the computer how to recognize different road traffic signals. So how to recognize different road traffic signals is what I want to teach the computer. So now let's go. I'm going to take the folders one after the other. So first thing first, we want to look at what is inside the folder. Let's read the folder. I want to read the folder. So I'm going to read the folder now. So let me bring in the libraries. Let me bring in the libraries we are going to use for this. So I believe many of us are going to come back after this to check this. So let's look at this. Look at the libraries, various libraries we are going to use, and the TensorFlow, the load image, and every other thing. So now let's run this. I'm going to run all of these images and these libraries. And so these helper libraries will help us to build what we want to build next. So we are done with the first part. We are going to the second part. All right, so now. Yes, our codes are Python. They are all Python codes, although we are using them in Jupyter Notebook. So as long as you fill in the attendance form, you are going to get the link to the materials and all that is used here. So now we have our data here. We've imported the required library and we've imported the required library. So now let's look at how we can read in the data and all of that. So let's read in the data. Let's do that quickly. And so I'm going to do what we call, I'm going to go deep down into my OS. I'm going to do what's a digging. So let's look at, so I'm going to use my OS model. So I'm going to get my get current working directory. So get CWD and so this like this. So get CWD. So this means that get my current working directory. So I'm in my master class. So what I want to do with the current working directory is that I want to join it with my data folder. So I'm going to do os dot paths. So I'm going to do os.paths.join. So I'm going to open this, close this, and then os.paths.join get current working directory. So I'm going to tell you that, well, so what I need is this. I need my data. I need my data folder. So data folder, and then I have inside my data folder, I have my car. Now inside the car folder, I have my directory. So I have my directory. So I have my directory. So directory. And then inside this directory, I want to add whatever I want to add here. So this is the basic structure I'm going to use. So now I've been able to build this part now. So this will now form my root directory. So root directory. So now the thing is, I also now do it. Remember I told you that I have 3 directories. I have the test, I have the training, I have the validation. So what I'm going to do is that I'm going to create a function that will help me to read data. The only thing the function does is just to read data, nothing more. So I have my read data. So I have my read data and I'll specify my directory name. So directory equal to, so my default directory is my training directory. So I'll tell you that use my default directory to be my train directory. So I'm going to change the directory here. Let me clear my screen. Let me clear my screen. So I'm going to change the directory here, and then I'm going to make it like this. So I'll now make this very dynamic, because what I did here before, it's not going to tell me the name of the directory per se. It's just going to write directory. So now I want to make it dynamic. So I'll put what we call our F string. So it has become very dynamic. So I cannot tell the computer that, okay, so this is the particular, I cannot tell this is the particular model I want to work with, this particular directory I want to work with. So look at the other things in the directory. So I'm going to say my class name, the name of the classes, and then I'm going to get different image paths. I'm going to get the different image paths. So I'm going to import the other parts and explain them now. So I'll import the other parts for our time's sake and explain what they are doing. Okay, so I have these several codes I've written before time. So what does the code say? What is this code telling us? I have what we have. So in my folder, so for each root directory, in the root directory for the data I'm working on. So what I want it to do is that it should tell me that, okay, tell me all the folders that are there. So I know that there are 2 folders. One is the image and one is the label. So I now tell you that, okay, so once you get to the image folder, open that folder and give me all the files that are there. Then when you get to the labels folder, open the labels folder, extract the text from the label folder, and then give me back what I call a data frame. So now this particular data frame is going to be what will give us our data. It's going to be the format with which we are going to store our data. So I'm going to get 2 things. I'm going to get images and I'm going to get their labels. So this run here. So this will run here, and then okay, you don't have to memorize this code. Over time, with use, you'll be able to know how to come up with those code. So I'm copying and pasting them because of time constraint, but in real world, over time, when you start using them, there's a logic behind getting all of this code. You already know what to do, where you want to get information from, how you want to, so you now start putting all of those things together to form this. So there is no need for memorizing. Just know the process and you are good to go. Does that answer the question, Mayowa? All right, so now we have our data frame here. So now let's use it to load our data. So I have my training data. So I'll have my training data. I'll read from my data like this. So read data. And remember, I said my default directory is my training data. So I don't need to tell it I don't need to change anything here. So the next thing I want to do is my test data frame. So I'll give it this. So I'll give it this read data, and then I have my read data, and then let's do the validation data. So I have my real test and then validation. So now I'm going to put here test. So I'm going to put here test, and I have my validation DF, and validation DF is going to be read data valid. So that's the name of my file. So we would have actually opened it, and then I would have opened it, but because of the size, so we don't be stuck here and then trying to open the file. All right, so now we have our valid. Okay, so it say part is not defined. All right, so where is parts? Where is parts? Where is parts? Dot. Okay, parts. All right, so here is it. I have my part. So you can see if I'd crammed it, I would not have known where the image, the error is coming from. So it's not something you cram. You have to know it, and then you can apply it. So now that I've known it, I've been able to apply it, and then I can run my code. You can see that everything is working fine. So I have my data frames, one for training, one for testing, and the other one for validation. All right, so now what is the next step after this? You want to process your image. So I'm going to give us the code for processing our image. I've done that prior to this time so that we will not have to repeat that again. All right, so let's process our image, and let's see. Process our image, and let's process our image and see. Okay, so now we now have our image processing. So I have a module for my image processing. I also wrote it as a function. Now, the reason I'm writing it as a function is because when you write it as functions, functions keep your code very organized, and it allows you to be able to use it many times. Imagine I did not write this as a function initially. So imagine I did not write this as a function initially, it would have been very hard for us to get it done. So now I've written it as a function. I'm going to run this. So now what I'm doing here, basically, I'm telling you that, okay, so for each data frame that you get, what you need to do is that you need to convert. You can see what we did earlier on. First, read the image. When you read the image, the next thing you want to do is that yes, you are definitely going to be taught how to write these codes. Yes, you are going to be taken through the whole thought process, and that you can sit down and come up with your own codes. All right, so now we have this convert color. So I'm reading in my image. After reading in my image, I want to convert it to gray. Remember why we converted our image to gray the other time? So that we can have less data to work with. So now I've converted it to gray, and then I have my read image convert to gray, and then I'm now resizing the image. Now, the reason I'm resizing the image is because I want to make sure that all the images are the same, so that one will not be bigger than the other. Everybody must be the same size. So I'm resizing the image, and I'm giving them the size I want it to be. All right, so now let's read this and see. Let's read this and see. Okay, so we have finished running this. So now let's test this. Let's use this to convert our image. So I have what we call my X string. So we used to convert our data into two types. We have the X-axis, and then we have the Y-axis. So the X is our feature, the Y is our label, the target. All right, so now we have the X string and Y string. So this is going to handle our process data for process image for our training data. Then I have my X test and my Y test. So this is going to process the image for our, this is going to process the image for our test DF. And then we have All right, I can hear you. All right. So now we have this. So I'm processing my images. So if all things being equal, I shouldn't have any error here. Everything should run smoothly and in order. So let's watch what happens. How long does it take? So sometimes you have to be patient. So as you're coming to learn data science, you're also going to come to learn to be patient because until your code is done running, there's nothing you can do. You just have to wait. All right. So now that we are done waiting and then we are done waiting, it has finished running. And so, okay, I think I'll leave that for Aisha to say. So we are done running this part. So let's go to the last part, which is the most important part for us, is that I'm now going to create my deep learning model. How many of us have heard about deep learning before? How many of us have heard deep learning, the word deep learning or a deep learning model? How many of us have heard it? Let me see your hands. Maybe a thumbs up or an emoji if you've heard it. If you've not heard it before, it's not a crime though. So let me know if you've heard it before. Okay, so now I have my, oh, all right, all right. So now I have my deep learning model here. Now I'm not going to train my deep learning model. And the reason I'm not going to train my deep learning model on this call is because if I'm going to train my deep learning model on this call, we are not going to finish today. So I'm going to I'm just going to show you how the whole training will go. I'm not going to complete it, but I'll just show you how long it's going to take. So now look at my model here. So I already have my deep learning model. I have this. I have this now. You can see I'm using CNN, convolutional neural network. So if you have heard that before, it's convolutional neural network. And so you can see my image 416, 416. So 416, 416, remember our data processing where I converted our image to, when I resize the image to 416. So 416, 416, this is it. Now this one is telling us that our image is not a colored image. Our image is actually our image is a grayscale image, and that's why we have the one there. And so we have other parameters, a mix of convolutional layers, convolutional this and that. And then so here, finally, I need to show you this guy. I need to show you this guy. And this guy here is our output layer. Is the one that we are going to tell that, okay, see, in this our data, we have plenty of in this our data, we have plenty of this. We have plenty of row signals we want to check, but all our row signal, all of them are, so yeah, it's a deep learning, it's also an advanced machine learning model. It's an advanced machine. I can actually use, after the data processing, I can actually use machine learning for this, but I just chose to use CNN. I can use SVM, I can use SVM, I can use yes, you can use PyTorch instead of using TensorFlow. You are free. All right, so now we have our dense data here. So this dense, which is the final output layer, is telling us that what we have here is a 15, an image of 15, and that means we have 14 classes in our data, 14 different classes that we are training for, and we have 14 data that we are training for. And then, so let's go to the final thing here, and which, like I said, I'm not going to run the model, but I'm going to give you the code I'm using to run the model. I'll give you a snippet of how the model will run, but we are not going to do that part. All right, so now let's look at this, fit the model. And so here, I've defined my model. The next thing I want to do is to compile the model. And when I'm done with the compiling, I want to fit the model. All right, so let's fit the model. I'm using 10 epochs. I've told it X train, Y train. So I'm not going to do that, but I'm going to do something very basic, very, very, very basic. So let's check for these. And so you can see this is how it's going to start running. By the time you get to this page and it's not giving you any error, that means you're on track, you're on point, everything you are doing so far is awesome. You are good to go. All right, so you can see how long it's taking me to even get started. And I'm going to 10. Already it's telling me that I need 21 minutes for one, and I'm going to 10. So you can see that it's not viable for us to stay on this course. So I'm going to stop this, and then I'll just show you what the final model looks like. So I'm going to stop this. Yes, so now the final model, let me go back here. So let me move up a bit. So this is what my final model look like. I have my CNN model.keras. So I'm going to now use that model. Remember our task. The first task is to identify if it's a road traffic signal. Then the next task is that we want to take that and then we want to classify that task. So now I've already saved my model. So I'm going to load the model into the workspace for us and let's see how we can make use of it. And that will be all for tonight. So let me load the model and let's see how we can make use of loading the model. All right, so I need a library that I'm going to bring in now. I need a library that I'm going to bring in now. So TensorFlow library. So this is my library that I'll use to load the model. So I'm going to give the model a name. So model equal to my model, I'm going to load my model. Remember the name of my model is that CNN.keras, CNN model.keras. So load model, open, so CNN model.keras. So loading. All right, so done loading. So let's quickly see if it will detect what kind of data this is. So let's see. All right, so let's give it an image. We uploaded it, so let's give it an image and let's use the image to detect it. So, well, you don't have to know all the steps offhand, but over time, the one thing is that this is a master class, so we are doing everything on one sitting. In a real world scenario, you are not doing it on one sitting. What I'm doing now can take us days. You can see that I skipped a part. I did not write all the code. I copied some parts and pasted it. So that tells you that it's not on one sitting, but over time you need to know them. That's just the thing. You need to know the process. So then you now start fitting it. It's not a one-day job at all. So all of these things we are doing, by the time you go back and practice, some of you might be practicing 2-3 days, you are still practicing. All right. So now let's go back to our image. Let's see what our image is telling us. Now I'm going to do something now. So let's look at this image. Let's look at the name. So the name of this image is 005 and all of that. So let's go back and see. I want us to use this image to do the data training. All right, so I'm going to copy a snippet of code I have here so that I won't have to start everything now fresh. So I have my model here. So I'm reading this image. So I'm going to specify the name of that image. So remember our image is, the name of our image, okay, let me have my data here, Control Z. So my data is that image we're trying to work on. So which is f of, let me open bracket, f of data slash this. All right. So now we are trying to work on this data. We are trying to read it. Let's see what class this image belongs. Let's see what class our model is going to tell us that this image belongs. So I've run my data. It has helped me to resize everything here. So look at this. I resized everything, converted to grayscale. I read it as grayscale here, converted to 416, doing my resize, copy, I minimize this, I normalize rather, and then I'm reshaping this. So one batch and all of that. So that is being processed. So let's now use our image to make a prediction. So prediction of the image. So how do we now use the image to make prediction? So we have this, I run this, and then it has predicted my image for me. So let's look at what the prediction says. So the prediction is giving me plenty things. So I don't know what all of these things are, but I know how to find out. So what I'm going to do is that there's what I call my argmax. So I'm going to introduce my argmax into here. And then that my arguments will tell me that, okay, so position 7 is my argument. So the argument is class 7. So it's telling me that this image is a class 7 image. So how do I verify that this image is a class 7 image? So let's go back to the original data set. Remember the name of the image. The image is 005 this .jpg. So let's go back to that image and quickly verify and see whether what we did is correct. So the name of our image, remember, is our training df. So I want to say where the image is equal to training image. So I want to put this here. So let me copy this. So where the image contains this. So where the image is equal to this particular name, and that is where our data is from. All right, so now let's see how that works. Let's run it and confirm. And then once we confirm, then that is all, we are done. Okay, so now this here. All right, so I put the appropriate image here. So I have my train DF, and so then put my N here, and I have this here, and so so I should have an image like this, trying to search. All right, so I'm trying to search for the image here, and then just train GF image. So dot head. All right, so I have this, and I have all of this, and then so I want to see. Okay, so it tells me that this thing is in class 7. So I'm going to check where the label is 7. So I want to verify that this image is actually giving me what I want, and then so this is equal to 7. So train of these and then class 7 images. So so I'm trying to search for the image there, and one. Okay, sorry. Yeah. Image. All right, so I've been able to search out the image, and then I can see that in this particular here, so I'm wondering why this didn't give me. So probably I had a mistake when I was copying this image here. So let me copy again. All right, so All right, so you can see that it tells us that this is in class 7, and our model also predicted that this image also is in class 7. So that means this image is in class 7 of images. So that tells us that our model for this particular prediction has been able to perform very well. So we can actually do some other checks and see whether those performances are there, and then we can optimize and get everything else done. All right, so that is it from my end, and this is how we convert data to useful image. We convert our images to useful data.
Yeah. Thank you very much, Daniel. Thank you so much. This has been really, really wonderful. Okay, this has been great. This has been exciting. Daniel has taken us through a very, very fantastic journey, an amazing journey. It's been a what's the phrase now? It's been very, very immersive, and I know that each and every one of us we also learned a lot. So, and for many of us, we might not have been able to follow along, which is fine. So Daniel, you can stop sharing now, okay? So we might not have been able to follow along, which is fine. So all you need to do, ensure you fill the attendance form, which has been sent to the chat box by my colleagues. So just fill that form and fill the form, and you get access to the recordings, the materials, the slides, so you can also practice this yourself. And yeah, so for some of us, we might be like, okay, what's going on? It's just writing codes, it's just writing code. Don't worry, it's very, very easy. That's the reason why we start from the building blocks. So we tell you everything that you need to know. We start from the point where okay, you have no idea, you don't know what you're doing, and we start from that point and build you up to that, to the point where you can go ahead and you become a fantastic data scientist. So you don't need to memorize the code. Okay, you need to have an understanding of it, and when you have that understanding, all of those things will become child's play, because yeah, it's amazing. So thank you very much, Daniel. That's fantastic work. We built a model that was able to identify signs, stop signs, all of this kind of stuff. And that's also the technology. A similar technology is used in self-driving cars, just like Daniel mentioned, where you see where the cars are able to identify signs and things around the road. So it's been really, really great. Thank you very much, Daniel. Okay, so I'm here now. Remember earlier I mentioned that Daniel was gonna come in, tell us about everything about how we can build the model, all of those kind of stuff. And then I will come in, and when I come in, they would have some fun. Okay, that's I will come in and we would have fun. And I'm here now, so it's time for us to have some fun. But just to confirm if everyone is with me, if you're still with me, okay, I want you to send ice cream to the chat box. For those of you that this is not the first time you're joining any of my sessions, you know that I always talk about ice cream. Okay, so if you're with me, send ice cream to the chat box. I need to know that we are all together. Okay, Adams, are you with me? So Muinet is with me, fantastic. Adim Mayowa, are you with me? Tony is with me. Ephraim, are you with me? Caprice, are you with me? Kinde, are you with me? Olorun Tomba, are you with me? Paul, are you with me? Rosemary, Tammy, William, Yemi, are you with me? Okay, fantastic. Okay, ice cream, ice cream, ice cream. Yeah, I scream, you scream, and we all scream for ice cream. Yeah, good to know that we're together. So let's have some fun, right? And something that we have to understand, because we've spent a lot of time, we've spent over an hour now taking a look at an aspect of data science. We've taken a look at building a model using Python, of course, working with the Jupyter notebook, but the language that we worked with is Python. But really, who is a data scientist? Because why everything that Daniel did is exciting. We also have to understand who is a data scientist. Is a data scientist someone that just writes codes in and out, writes codes today, writes codes tomorrow, writes codes forever? Is a data scientist someone that is always trying to build models, always writing Python codes? Is a data scientist someone that builds AI models? Is a data scientist someone that can see the future? Who is a data scientist? So that's the first thing we take a look at. Because if you're looking to get into this career path, it makes sense that you should know what it means to be a data scientist or who really is a data scientist. Okay, so a data scientist is a fantastic professional. A data scientist is a professional who analyzes complex data. A data scientist is a professional who analyzes complex data to extract meaningful insights, build predictive models, and solve business problems. A data scientist, number one, a data scientist analyzes business data. A data scientist focuses on two main kinds of analytics, on two main types of analytics. That's your diagnostic analytics, your descriptive analytics, and your predictive analytics. The diagnostic or but let's begin with the descriptive. The descriptive analytics, descriptive analytics is talking about what happened. So descriptive analytics, descriptive is talking about what happened. What happened? That is you taking a look at historical business data and trying to identify trends and patterns. Oh, last year you took a look at the data, you analyzed the data, and they noticed that last year or last month we made $5,000 in sales, or we made $10,000 in profit. Okay, last month. So what did we do right? Maybe the projections for the business that we're going to make 5,000, but we made times two of that. So what did we do right? What were the things that we did that actually made us make that kind of profit? So you then get to take a look at that. Oh, this is what we did, and try to replicate that. That is talking what descriptive analytics is all about. Describing what happened. Because as a business, you want to take a look at data. Every one of us, we have all analyzed data at some point. Let's say you have a business, you have a spreadsheet that you note down your sales, or maybe you have a ledger. You taking a look at your past data to understand what has happened is descriptive analytics. And then number two kind of analytics is the diagnostic analytics. Okay, diagnostic analytics. And the diagnostic analytics is talking about why did it happen? So we have what happened, and then we have why did it happen? The why did it happen is, okay, so now the example I used earlier, right? We've taken a look at the data and we've seen that we made $10,000 in profit. But why? What did we do that made us make that amount of money? So if it is positive, we can replicate that same thing to ensure we make that same amount of money in the next month. And if it's a negative scenario, maybe we made $10,000 when we're expecting to make $20,000. So we do something different to know. So we do something different to get better figures in the next month. Diagnostic analytics is answering the question, why did it happen? Descriptive, what happened? So descriptive, what happened? Okay, what happened was we had 500 customers. Why? Why did it happen? And these two questions are answered by analyzing data using analytical tools. And lastly, we have the predictive analytics. We have the predictive analytics. And this answers the question, what will happen? What will happen? So predictive analytics is you now looking into the future and telling the business that, oh, from what I've seen, from my forecast, I can see that in the next 2 years, we're going to have a decrease in sales, or in the next 2 years, we're going to have an increase in sales. Descriptive is looking into the past. Diagnostic is talking about why, and predictive is looking into the future. All of this encompasses what it means to be a data scientist. That is why earlier I mentioned that a report came out that said data science is the sexiest job of the century, and this is the reason why. One profession that has all of the abilities that you can think of. A data scientist is just like a superhero. You can look into the past, you can understand why things are happening, and you can also take a look at the future. I think we should have a sci-fi movie for just the data scientist because their powers are phenomenal, if you ask me. A bit of predictive analytics is what we actually did today. That's building AI models. So again, a data scientist is not just about coding, because we need to understand what are we even coding for. Okay, we answer three questions: descriptive analytics, diagnostic analytics, and predictive analytics. And all of this has to do with what? With data. Everything I've said so far, everything I've said, a summary again. A data scientist, they visualizes data. That's taking a look at your descriptive and your diagnostic analytics. So this is the past data. This is historical data. Historical data. We have data in the data. We have data in the spreadsheet, data in the database, whatever the organization uses. We have lots and lots and lots of data. But we need to understand the stakeholders in the business, for instance, they need to understand. Since we have so much data, we want to know, what does the data really say? There's this popular phrase that says that if we have data, let's look at data. And if all we have are opinions, then let's go with mine. So no one cares about your opinions any longer. Companies want to know, what does the data say? That is the reason why you convert the data from its raw form, its raw format, from its previous state where it was not easy to understand. You convert the data from all of this, and then you create a report, also known as a dashboard, that is now able to answer the questions that the stakeholders have. That is now in a format the stakeholders can understand. So this will be converted into this. That is your descriptive and your diagnostic analytics. And then lastly, we have the predictive analytics. The predictive analytics, that is where your AI models come in. You building models. You're going to be building models that will be able to detect. The model we built right now is a model that can detect objects, leaning into computer vision. That's what we did today. We just took a little bit into computer vision. And as a data scientist, you would also be building models that can predict, models that can see into the future. So maybe the stakeholders want to know, so what are the projections like for the next 2 years in terms of sales? The next 2 years, how in the world is someone going to know what is going to happen in the next 2 years? It's possible. The data scientist can know. So the data scientist then takes a look at the data, builds a model using different tools, and then the model will now take forecast. This is what's going to happen. There are different ways forecasting can be done. You can forecast using Excel, Microsoft Excel. You can forecast using Python as well. The model that will be built, there are different things that are going to be taking a look at. First of all, you have to determine the kind of model you want to work with. We have different models like the random forest model, and then you also have to determine, okay, and work on, should the model be more accurate or should it be more precise? Accuracy and precision. There are two different things when it comes to predictive analytics. These are some of the exciting things about data science. Data science is an exciting career path. Fantastic, fantastic. It's so exciting because of the things that you are able to do. Remember, you can look in the past, you can understand why, and you can look in the future. Tell me a career path that also offers that. None. I'll answer the question. Okay, so that is what data scientists do. And what do you need? What do you need to learn? Okay, so for you to be a data scientist, what do you need to know and how do you need to learn? To be a data scientist, there are several things that you're going to do. There are several things that you're going to need to learn, several tools like your Excel, your Tableau, but we're going to get into that. So we see how you can move from where you are at the moment and become a full-fledged data scientist. But first of all, is data science actually career getting into? Because at the end of the day, it's not just about, is it flashy? Because trust me, data science is flashy, but is it worth it? There's this parable, I think it's a parable, or is it an idiom? I think it's a parable that says, not everything that glitters is gold. So you have some things that glitters, but they are not gold. So in this case, we are trying to get gold. Is data science gold? Because of course we know data science glitters, but is it gold? Let's take a look. Before we decided to offer the data to have the data science program at Analytics, there's a lot of things that we did. Remember, we are here to make your dreams come true. And so to do that, we have to ensure that we get everything right. That is why before we went ahead to decide, okay, you know what, let's have a data science program. We did lots and lots and lots of research from web scraping, which is the one I'm going to focus on, where we scraped different job boards from LinkedIn to Indeed to Glassdoor to Total Jobs, CV Library, Monster, Google Jobs, just to list a few. We scraped different job boards across the UK, the US, and Canada. And after scraping, we're able to get all of this data in a database. All of this data, that's all of the data in a database. And then we went ahead to analyze. So we analyzed the data. We analyzed the data looking at 3 different criteria, from ease of learning to ease of transitioning and also high rewarding salary. Ease of learning means that a career that you can go ahead to learn in less than, let's say, 1 year tops, 1 year tops. You can get everything you need and be able to land the job. Not a career that you have to spend 6, 7, 8, 10 years learning, as if you want to become a surgeon. No, something you can learn quickly and then you'll be able to transition, because we are adults, we have all the lives. Anything we do right now is to make anything we do right now, we want to ensure that it's something that we can get results as quickly as possible so we live better lives. So ease of learning. And then we have ease of transitioning, which is focusing on the part that you need to transition into a career that it's easy to transition into. That you need to be able to transition into a career. That there are so many opportunities available that you don't need to have some sort of background to be able to transition. In data science, you don't need to have a master's in data science for you to be able to get a job as a data scientist. No one cares. No one asks for that. So you don't need to have some sort of background. And there are so many there's so many opportunities available for the data scientist. So many opportunities. As a data scientist, you can function as a data analyst and also as a data scientist as well. So many opportunities available. If you go on any job site right now and you search for data science roles, you will see that you have nothing less than 100 job roles uploaded just today. In just one job site, not in everything, just one job site, not less than 100 roles uploaded just today. So what that will tell you is that you can go ahead to apply to jobs that you know are still very much open, and not like you're applying to jobs that were posted 3 months, 2 months ago. So you know for a fact that these jobs are very much open, number one, and also that you can go ahead to apply to jobs that you know there's several opportunities. So if you decide I want to apply to 20 roles in a day, it is very, very possible because the jobs are there. And of course, high rewarding salary. You want to move into a career that, as much as you will be able to get your needs, okay? You want to move into a career that, as much as you will be able to get your needs, you also want to be able to get your wants. Wants. You want to be able to get your needs and also your wants. I believe in the life philosophy that it's not just about being able to afford housing, clothing, and nutrition. No, you should still be able to get that bag that costs a lot of money. You still want to be able to eat out when you want to. You still want to be able to travel, to live life. So whatever career you're looking to transition into should be one that also offers all of these opportunities. So these are things that we took a look at before we came across the jobs, before we decided on the programs, on the careers that actually contains these 3 different things. and that is your data analytics, your data analytics, your data science, your HR analytics, your cybersecurity, HR project management, and also your I think I mentioned data science and business analysis, of course. So what we are focused on today is data science, and that's actually one of the roles that offer this. Remember, there's something I said, and I don't know if you guys remember, that as a data scientist, you have so many opportunities available. There are so many roles that you can function in. There are so many things that you have. And the reason for that is you can, and the reason, just give me a moment. Um, okay, and the reason for that is you're taking a look at the three different kinds of analytics: predictive, diagnostic, and also what? And also descriptive. So the career paths that offer these three different features, that's ease of learning, ease of transitioning, and what is salary, are all of the different career paths that you can see on my screen. Amazing, right? So this is just something that we took a look at. This is just something we took a look at. But because we were the one that actually carried out this research, we understand as a data company that there is tendency for bias. So we wanted to reach out to another organization. We wanted to take a look at the research, the reports of other bodies that do not have a direct relationship with analytics, at least at the moment. That's how we came across the World Economic Forum. So the World Economic Forum releases a report every 2 years called The Future of Jobs. And what this report shows, it shows the roles that are going to increase in terms of demand and those that will decrease. The number of jobs that will be created and the number of jobs that will be destroyed. And as you can see from the from this report is a report that is available to everyone. So you can go ahead to fill the form so you get access to the slides, so you can download the full report, or you can just go over to Chrome, your browser, and search for World Economic Forum Future of Job Report, and you'll get this. It's a long read, about over 200 plus pages, but what we're interested in is on page 32, if I'm not mistaken, and that's what you see this. So the rows by the left are job roles that are going to increase in demand, and the rows by the right are job roles that are going to decrease in demand. And the rows by the left, as you can see, we have the AI and machine learning specialist. This is actually a role that a data scientist can function in. Machine learning, that's moving into the realm of what? Of predictive analytics. Then, of course, we have the data analyst and scientist. This is just stated explicitly that if you don't understand machine learning specialist is a data science role, I'm just going to write it out for you. This is a report that was not carried out by us. No, this is a report that was carried out by the World Economic Forum. So this is what they are saying. And you can see they are growing with analytics. That is, there are so many opportunities available for you in data science as a career. So if that is the path you're looking to get into, then by all means do. Amazing, right? And one great thing about the data science role is that, like I said, there are so many opportunities for you. As a data scientist, you don't only get to function as a data scientist, you can apply to roles in data analytics, you can work as a data scientist, of course, you can work as a machine learning engineer, as a forecasting analyst, a demand plan analyst, a big data analyst. All of those roles are available for you. So you just have like a sea. It's like you have a sea with all the fishes, and it's just for you to go ahead and have a delicacy. Amazing. But what will help you land that job? What will help you get the job? Because is it all about just getting the skills? What is the approach? What are the things that you're going to need to do from step 1 to step Z before you get that job? It's easy. The first one is that you need to identify your career path. That's the first thing. You need to identify, what do I want to get into. That's the reason why you're in a session like this, because you're taking a look at different programs and saying, okay, I think data science is for me, or I think data analytics is for me, or I think cybersecurity is for me. Which should I choose? Mini, mini, many, more. Okay, so you're thinking, which should I choose? So at this point, let's say you decided, oh, I want to be a data scientist, or I want to be a data engineer, or whatever. So you've made a decision, and then what's the next thing? You begin learning. You begin learning. And the way you learn is that you learn using two different approaches. You learn with the self-paced learning, that's the LMS, Intelligence LMS, and you also learn as with the live classes. So you have the self-paced learning and you also have the live classes fused together. So it doesn't matter if you're the kind of person that prefers speaking with someone, you want to join a call, just like what we are doing at the moment, where someone is speaking, you are asking questions, or if you're the kind of person that prefer watching a video so you can go back as many times as possible before you understand, there's absolutely no problem. You are good to go, looking at the way you will be learning the skills. And then the next thing is that you have to gain project-based experience. Because let's be honest, I'm not here to feed you fables. For you to get a job, you need to have some sort of experience. People say, oh, once you are looking to transition, start applying for entry-level roles. But I don't believe in entry-level roles. I have never seen an entry-level role. What's an entry-level role? An entry-level role is a role that requires you have no experience. And when you go apply to jobs, usually say things like you need to have maybe 1 year experience, 2 years experience. You need to have some sort of experience. So you might be wondering, if I don't have experience, how do I get a job? And if I don't have the job, then how do I get experience? How is that going to work? That's where project-based experience comes in. And that's the great thing. Because many people don't know that there are two ways you can gain an experience. The only thing there's just one way, and that's force. So you gain project-based experience by working on relevant projects, by building an actual portfolio. If you're looking to transition into tech, the portfolio is something that is very, very, very important. You need to be able to showcase your work. You need people to be able to see that, oh, you can actually do several things. You need to be able to show the recruiter that these are the things I've worked on, and you need to be able to put your best self out there so they know that you're very, very much capable. So you gain that project-based experience, and then what's the next thing you do? The next thing you do is that you also gain employability skills. Because yeah, you have the technical skills, but that does not mean you're going to get employed. You also need to be able to show yourself rightly to the recruiter. You also need to be able to position yourself rightly in the market. You need to know how you can have a great CV that will pass through the ATS. You want to ensure that when you actually apply to jobs, that you are actually applying. You want to ensure that when you apply to jobs, that you are actually in the running. And the way that you can do all of those things is by getting the employability skills. From CV review to your LinkedIn optimization to navigating the job market, you understanding how to navigate the job market in your current climate, to getting a job reference letter when the need arises, and to getting that on-the-job support for when you eventually get that job. These are things that you would also need to get for you to be able to transition. And then you need networking and mentorship. You need to be able to speak with industry leaders, people that have been able to succeed, where you're looking to succeed, that will take you through everything you need to do so you also succeed. And you need to be in the community so when there are opportunities, you are aware, because the truth is, when organizations are looking to recruit, there's a recruitment hierarchy, and the number one is referral. First of all, they take a look at the internal organization, if there's anyone in the company that can, step in that role, and they move to referral. Then after referral, before they start looking at others. So if I have an employee in my company that is telling me, oh, I feel this person would be good for the role, I will take a look at that person first of all, before I go out there and start asking people to apply. So you want to ensure you have a good network. And then that's how you get the job. And then you start celebrating. Celebrate, people celebrate. Okay, so that's how you do it. You start celebrating, and that's the approach. That's the six-step approach from you moving from point A to getting to point Z. But which skills do you need? Okay, we've seen the things you need to do. We've seen the six-step approach. We've seen how you need to start from step A to land to get to the point where you can get a job. But what are the skills you need? And when I say skills, I'm talking about the technical skills. Because as a data scientist, there are several things you need to do. And what are those things? The first thing, you need to understand statistics. As a data scientist, statistics is one of the things that you need to know, because you will see how, and when I say statistics, I'm not just talking about, your mean, median, mode. You then get to understand how you can apply statistics in business. So what is the relevance of mean when you're taking a look at a business? What are the relevance of median when you're taking a look at a business? Because at the end of the day, probably the only thing we learned in school with regards to statistics is that you just use it to compute numbers. But what is the actual relevance when it comes to business? You get to see all of that. And then you learn how you can forecast and also carry out predictive analytics using Excel. Your Tableau for data analytics, which is what will help you when it comes to your descriptive and your diagnostic analytics. Then you learn SQL for querying databases. That's your structured query language. Then before you begin learning Python. In Python programming, you start from the basics. So today, everything we've seen might be a bit confusing. No problem, you don't need to fret. Because we start from the basics with the building blocks, first understanding data types, loops, functions. Then you move on to your exploratory data analysis, which is your EDA, how you carry out your EDA on large data sets. Then you move into your machine learning, your computer vision, which we took a look a bit at today, and also how you can use GitHub for version control. Then you move into your ChatGPT and GitHub Copilot for coding, and also your Microsoft Fabrics for analytics. Those are the key learning areas. Those are the things that you have to understand. So the tools and technology, Excel, like I said, your Tableau, your SQL, your machine learning, GitHub Copilot for version control, all of those things. And the average pay, the average salary, the median salary when it comes for data scientists in the UK, for instance, is 55,000 pounds in the UK, 55,000 pounds. And then in Canada, it's 94,000 Canadian dollars. And in the US, it's 121,000 US dollars. That's the median pay. Median means that you're going to have data scientists that earn above this, and you're also going to have those that earn slightly below this. But what's the learning time like? You learn on Saturdays and Sundays. So on Saturdays, every other Saturday, so not every Saturday will you be having a class. You're going to have classes on Saturdays. And then for the Saturdays where you have no classes, you'd have your self-paced watch me do it videos. Remember, you're using on an hybrid format to learn. You have the Analytics LMS, and you also have your live classes. So for the Saturdays where you have your classes, you have two classes. It doesn't matter if you're in Europe, in the UK, in Africa, or if you're in North America, there is a class for you. So in the UK, if you're in the UK, class time is 11 to 2 p.m. UK time. Okay, that's 11 a.m. to 2 p.m. And then if you're in Canada, you're in the US, classes from 6 p.m. to 9 p.m. West African time, which is 11 a.m. So now we're done with daylight savings. With daylight savings. So that's 11 a.m. to 2 p.m. MST. And then, of course, don't forget you have your Watch Me Do It videos for Saturdays where you have no classes. The learning timeline is for 8 months. So you get to learn for 6 months. You have 6 months of intensive learning, and then you have a 2 months internship, 6 months learning, and 2 months internship. And one fantastic thing about the internship is that you're going to have a very, very special opportunity to include Amdari and also 10 analytics on your CV. And that's because you'll be training with 10 analytics. During your 6 months, you'll be training with 10 analytics, getting the skills, learning everything that you need to know to be a great data scientist. And then when you move into your internship, you'll be interning with Amdari. So on your CV, you can have Tinalytics and Amdari on the CV. And you can also get a reference letter from either Tinalytics or Amdari when the need arises. Where else will you get this? Where else will you get this? This is absolutely fantastic. Okay, so absolutely fantastic. So everything I've said so far, we still have to understand. I talked a bit about the employability skills. The fact that it's very, very important, it's very, very crucial you get employability skills if you're looking to get a job, because you need to complete the job equation. And I'm talking about the T plus E that will get you the job. T being the technical skills, and then E being the employability skills. So your technical skills plus your employability skills will get you that job. What we define as success as analytics is you getting a job, not just you learning the skills. Because as I always say, that is a given. You are going to learn the skills, no problem. But what we define as success is when you've gotten that job. And we are very, very much successful because we've been able to help so many people transition into the tech space, transition into getting their first job in tech. And that's why, in addition to the technical skills, you get employability services from having your CV reviewed and revamped, to having your LinkedIn optimized, so you have your LinkedIn also optimized, to having the sessions where we bring in technical recruiters that will come in, people that are actually employing people that you submit your CVs to schedule an interview with. Okay, all of those people. We bring them into sessions and they tell you what they look out for in candidates. They tell you what they look out for in CVs. They tell you about the red flags and they also tell you about the green flags, which I think is even more important because you want to know the right things to sprinkle on your CV to ensure that you actually do get an interview and then you go ahead to land that job. Then interview preparation is something that you also get. So you've gotten the job, you've gotten an interview, but you need to be prepared. Okay, you've gotten the interview, but you need to be prepared. So you can reach out to us and schedule a one-on-one interview, interview prep session with a professional that will take you through everything you need to know and help you prepare for that interview. If it's a technical interview, if it's the first stage interview, whatever the case may be. Because again, our focus, our commitment is in you getting that job. I talked about the reference letter earlier. Recruiters nowadays want you to provide a reference letter. They need you to show that you actually do have working experience. They need you to provide some sort of guarantor that has to work with you, that will tell them that, oh yeah, I've been able to work with this person. This person's a fantastic professional. They will be an amazing addition to your team. So as long as you are a participant or an alumnus with analytics, you are sure of getting a reference letter from us or from Amdari. On-the-job support is something you also get. You've gotten a job, you've been given a task that is not so clear. You can reach out to us and would also guide you on what to do. So you go back to work and so you are flying. You are doing absolutely amazingly well. And weekly mentorship, where you are mentored weekly. Week in, week out, you have professionals that come in, they tell you what to do, how you can better place yourself to ensure that you get that job, how you can better apply for jobs, things that you might be doing wrongly, and things that you should correct to hasten your job getting process. then Upwork optimization for if you're looking to freelance. So maybe freelancing is your thing. You want to just freelance. You want to work 2 a.m. to 2 a.m. and sleep the rest of the day. Okay, no problem. That's the Upwork optimization session is there for you, where you learn how you can succeed in Upwork. People say that Upwork is difficult. There are so many freelancers on Upwork, it's difficult to succeed, but people are still succeeding. So we'll show you, bringing experts, Upwork experts, that will tell you how you can navigate through all of these and how you can succeed. From how you can write outstanding proposals to how you can ensure that your profile is attracting clients. So this is what you get. And also, something you'd also be getting is that week in, week out, you will be getting job postings. You will be getting job postings from Tenalytics. These are job postings that you get that you can go ahead to apply to. There are several documents we provide to you. We provide you with a document that contains over 20 different job sites that you can go to apply to jobs. We'll also provide you with the different job titles that you can look at for. And in addition to this, we are also going to be providing you opportunities like sponsorship roles and remote opportunities for you to go ahead to apply to, because we have accounts in different job boards. There are some premium job boards out there that you need to pay. You need to subscribe to get access to the job postings on the job boards. So what we've done is that we've applied to these jobs and then we scrape the data and we provide it to you. So you have premium access to these jobs that you would not see on LinkedIn. That's something that you'd also be getting to help you land that job. Because again, that is what we're about. Okay, so you also get access to personalized learning AI assistant, that is Oluko, because at Tenalytics we have our very own AI model, and Oluko is there to answer any question you have, from code-based issue to maybe you have questions about the course content or the course curriculum, because Oluko has been integrated with everything that we do at Tenalytics. So there's so many people we've been able to help, so many individuals that we've been able to help transition, that we've been able to help land jobs as data scientists, as data analysts, so many people. And we could spend all day going through all of these testimonials, okay? From how we're able to help Rita secure a tier 2 visa after completing our data analytics program. This just Rita. That's for those of us looking to move into getting a skilled worker visa, to how we're able to help Lois. Lois got a job as a project manager in the UK after completing a business analysis program. So how we're able to help Ngozi get a job as a business analyst with our experience as a customer service. So she had previous experience in customer service, but we're able to help her get a job as a business analyst, currently working remotely from the UK, from the Huddersfield in the UK, to so many people that we've been able to help. We can go through all of these. We're able to help Busola. Okay, that's Busola gets a job as a data scientist after completing a data science program at Tenalytics. So she got a job in Poland. And something we hear about Poland a lot is that, oh, Poland is very, very difficult for you to succeed. There's no opportunities there. But the thing is that we even had another participant, and I'm talking about Benga. Benga got two different offers in Poland. The same Poland people are complaining about that, oh, I need to leave Poland. There are no opportunities. We have people getting two different job offers. That's because we know what works in analytics. We know how to position you rightly to help you succeed. Okay, so many people, Abigail, Tony, Ramat, Muideen, to Abdul Rashid, so many people that we've been able to help. We've even had sessions. Where we brought in these people to join a call like this, and they got to tell you how they were able to transition. They get to tell you about their story, how they started, how they joined analytics, and how they were able to get that job. And these are the sessions I'm talking about. So please ensure you can go back, just join and just listen to any of the sessions and listen to those people speak. Many of them were currently where you are at the moment, and they've been able to get to where you're looking to get to. So you want to listen to them to say, okay, what actually made them join analytics and how were they able to succeed after joining analytics. Okay, so many people that we've been able to help. Okay, so many people. And we're also accredited by the American Council of Training and Development. That's to show you the quality of trainings that we offer, the quality of training we offer. So you know that when you get a certificate from us, your certificate is going to come with the ACTD logo. The ACTD logo is going to be on your certificate, and that is going to show that yes, you actually do have the skills you claim to have. So what are the next steps? The next steps is that you need to go register. That's the next step. And you need to be a part of the cohort starting on the 5th of April, April 5th. And for you to be a part of that cohort, all you need to do is go ahead to register. And the great thing right now is that we're currently running a discount, a 50% discount, a 50% scholarship for the first 300 women that are looking to get into any of our programs, and also 50 men looking to get into our programs. 200 women and 50 men to commemorate IWED and celebrate our amazing women doing amazing things out there. Okay, so this is the perfect opportunity for you to get into any of our courses. Many of you know that, okay, last month the prices, for you to get into the 8 months plan, you needed to pay $900. But this month we have a 50% off. 50% off. And this is only going to remain for this month. As soon as we are done with this, going into next month, the price is going to go back to normal. This is to commemorate the International Women's Day. So instead of paying the original amount, which was $900, you get that 50% off, and you get to pay $450 instead. And you can also break this down into multiple installments. You can break this down into 3 installments. So that is paying $150 for 3 months. And the way you make payments is that my colleague has sent in the payments link. So once you do, what you need to do is you click on that link, and it will take you over to the Analytics Enrolment Center. Now, over here, you can see, you can chat with Analytics. Maybe you're having any issues with payment, all of that. So you can click on this, and someone is at the back end ready to listen, ready to assist in any way possible. And you can also get access to all our program brochures by clicking on this link to see what we are offering in all of our programs. Then you can see again the discount is still running, so you want to ensure that you are a part of that. And over here, once you scroll down, okay, you get to select secure your IWD discounted slots, and this will bring you over to the page where you can make payments, select your tranche, and also make payments. So just wait for this to load up. Okay, so yeah, so over here you can see you have 3 different tranches. You can make a one-time payment, you can make a 2 monthly installment where you get to pay $225 for 2 months, and then you can also select tranche 3 where you get to pay $150 for 3 months. So as soon as you select the tranche you're looking to go with, you click on secure your seat, and this will pop up your payments timeline. So if you make payments today, your next payment will come in on the 26th of April, and then the final payment will come in on the 26th of May. So you go ahead and click on proceed, and once you click on proceed, what that will do for you is that you get access to, once you click on proceed, you get access to the payments pop-up where you insert your details, everything you need, and then you get to make payments. Your receipts will be sent to you via email, accompanied with a link for you to complete your payment, for you to complete your registration, sorry. So once you click on that link, you upload your receipts and you upload your details, you select the program you're looking to go with, and then you get a welcome kit. We get an email from us confirming your payment, accompanied with your welcome kit, which contains everything you need to be a part of the program, how you can get into the Analytics LMS, how you can also get into the classroom, the community, and all of that. So that's how you can register. The discount slot is running running very, very fast. Okay, so so far we've had, I think the last time I checked, if you also check our social media, we often post the numbers at every point in time. So the last time I checked, we've already had close to 180, that's close to 200 now, women that have already gotten into this program, that have gone ahead to what I've gone ahead to secure their discount slot. Okay, so you want to ensure that you get into that. So how much is the total amount of the course? The total amount is $450 because of the scholarship we're currently running. So scholarship for the first 300 men to register, and for the first 300 women to register, and for the first 50 men to register. So the total amount is $450, and you can break that down into 2 installments where you get to pay $150 every month for 3 months. Okay, so you want to ensure you jump on that as quickly as possible. So yeah, we've been able to help so many people transition. We've been able to help so many people land their first job in tech across the UK, the US, Canada, the entirety of Europe, and also Asia as well. And I know that you want to be a part of this. Okay, so ensure you go ahead to register as quickly as possible. I'm sure we had an amazing time. I know I did. Taking a look at everything we did from the start, where we worked on a project where a model was able to identify road signs, which was a computer vision project, when there's still what it takes to be a data scientist, and yeah, we have. Okay, so let's see if I have questions. Do I have questions? Okay, no questions. Okay, so no questions. So if you know you have a question, probably you have a question later on, what you can do is that you can go ahead to schedule a a clarity session. That's how we can help you get a job session. You can go ahead to schedule that, and you join us. We have that every day. So you join that, and you get to ask any question you want, and all answers will be provided. So you can reach out to any of the admins in the tech community on WhatsApp and ask for the link to book a clarity session. Okay, so I can see some questions. Okay, so is the cost for, I believe Along Toba is trying to access the discount only for data science. No, the discount is for all programs, not just data science. Okay, the discount is for all programs. The first 20 people to register getting a discount, does it apply to each cohort? For example, starting in May. First one to register, the first one getting this, no, at the moment, the scholarship, that's the 50% discount running right now, is only for April. Going into May, we are returning back to the original price. Okay, we are returning back to the original price. So except if maybe you're looking to make payments now and you want to defer it to May, okay, so we can take a look at that. But if you're looking to register in May, if you're looking to register in April to start in May, then you're gonna have to, you're gonna have to pay the full payment, because then the IWD month will be over. These IWD discounts, okay, and there's no IWD in April, is there? Okay, there's only IWD in March. That's right here and now. How much coding? What about business analysis and project? Yeah, so business analysis and project management, the discount is also included. Yeah, so like I said, the discount is for every program we offer. That's the 8 programs we offer at analytics. We have the discount across board. And iPod is asking how much coding is data scientist, and how can someone with the observed background breaking? So yes, there's coding in data science. When you're done with your SQL, when you're done with SQL, you move into a window with Tableau, SQL, then you move into Python, then you start coding. So yes, there's a lot of coding, but it is not all coding. But coding is not scary. I know today it might have seemed scary, but that's because we did not have an understanding of the building blocks. We are focused on the computer vision project today. Okay, that's the reason why it might have seemed scary today. So it's very, very easy. The way we teach coding is that we start from the building blocks. It's like Lego. I don't know if you have kids, iPad. Okay, was the iPad that asked the question? I don't know if you have kids, but if you do, you probably know Lego blocks. Okay, Lego blocks. Lego blocks you build. They're blocks you combine, and the kids can build amazing structures using Legos. But one Lego in itself, it's not complex. It's just a brick. It's for a brick. But when you've been able to place everything together, then it looks like an amazing structure. It becomes an amazing structure. And that's the same thing when it comes to coding. So coding has those building blocks as well, just like Legos. And so we teach you we teach you about the building blocks first of all. We give you that understanding. You work with, oh, this is a Lego, this is a Lego. And then after you've gotten that foundation, you yourself, you'd start putting things together and building amazing structures. That is just what coding is about. If we were to break down the codes that Daniel wrote today, you would see that they're just several building blocks. They're just different Legos that have been put together to form what we have at the moment. So please, if you're interested in data science, don't let coding scare you, because we are still going to help you out with all of that. So what kind of laptop will work better? So we usually advise that you go with a Windows PC. And the reason why we advise you go with a Windows PC is because there are some tools, for example, there's some tools, some applications that are not available on Mac. But that does not mean if you have a Mac, you cannot register for the program. Definitely not. So you can register. We'll show you how you can install some of these tools on Mac, but it's easier if you have a Windows PC. Okay, it's easier. So if you're looking to buy a PC, I would advise you to buy Windows. But if you already have a Mac and you're not looking to change PCs anytime soon, there's also no problem. You can actually go ahead to register, and we'll also help you out with all of that. Okay, so I think that's gonna be it for now. We're gonna end now. Any other question, of course, you can get booked for a clarity session. Like I said, reach out to any of the admins on the tech community, and they'll provide you with a link so you can book for that clarity session. One more question: is there coding in data analytics? No, there's no coding in data analytics. The only coding I would say is SQL, but I don't see SQL as coding. SQL is very, very easy. It's English. It's just you writing database queries. I don't see it as code. So there's no coding in data analytics, iPad, no coding in data analytics. Okay, so yeah, I guess that'll be it for now. Thank you everyone for joining in. I'm sure you had an amazing time. I know for one that I did as well. So please ensure you go ahead to register as quickly as possible, because as I always say, and as we also say, quick says the clock. Whatever it is you have to do, ensure you do quick. Go ahead and register and benefit from the 50% discount. And I'll see you all in class. Cheers, everyone.